All right, good afternoon, Spartan fans. In this video, I'm going to go over graphing in standard form. We're also going to review some factoring and talk a bit about the discriminant. Section 5.3. Okay, there is a quiz on Monday. Monday's quiz is on parent function graphing and completing the square. So this right here is not on Monday's quiz. So Monday's quiz, graphing and parent functions, completing the square, and there's going to be one factoring question. So 3 total questions. All right, so speaking of factoring, let's review a couple problems. So if I ask you to factor, and my suggestion is I'm going to give you a few problems, and my suggestion is that you stop the video, try them on your own, and then push play to see how you did. So these are the 3 problems I'm going to ask you to factor. X squared minus 4x minus 5, 3x squared minus 10x plus 3, and then lastly I'm going to ask you to factor 2x cubed minus 8x, oh no, how about minus x squared? My apologies. Minus 8x plus 4. Go ahead, pause the video, try these on your own, and then come back. All right, many different ways that you can factor. I would imagine that most of you learned how to do the diamond method, and the diamond method says that you take A times C and put it on the top, and B on the bottom. And what's A, B, and C? So standard form of a quadratic, which we're going to talk about in this video. Standard form of a quadratic is ax squared plus bx plus c equals y or equals f of x. So in this problem, AC is negative 5, B is negative 4, so what multiplies to negative 5 but adds to negative 4 is negative 5 and 1. This is one of many ways that you may have learned how to factor. I don't care which way you do it, you should do whatever makes the most sense for you. So some of you learned splitting the middle term and then grouping. Some of you maybe learned how to make the box. You recognize the box from completing the square. Some of you may have just learned guess and check, which is how I learned, which you know was eons ago. And it's x minus 5, x plus 1. Now, I'm doing this on my own. I'm super hopeful that I don't make any mistakes that you have to tell me about later. So this is the final answer. I'm going to show you a little bit more work and some shortcuts on this second problem. So the second problem starts with 9 on the top and negative 10 on the bottom. So what multiplies to 9 but adds to negative 10 is negative 1 and negative 9. Okay, so a shortcut way that you may or may not be familiar with that I think is just like super helpful is whatever the A value is, in this case A is 3, I'm going to take my side diamond numbers and divide by 3. And this is a shortcut that always works for trinomials, which is why I like it, because there's no exceptions. It always works. And then what you're going to do is, if the sides of the diamond actually reduce, so here, negative 9 over 3 can be reduced to negative 3 over 1. And normally we don't put the 1, but for the shortcut, it's super helpful. And so the shortcut says that the denominator of the fraction is the coefficient on the variable, and the numerator is the constant. and that's x minus 3. And then on the other side here, the denominator of the variable, the denominator is the coefficient on the variable, so that becomes 3x, and then minus 1. By the way, if you set this equal to 0 and solved it, that is incorrect. I did not ask you to solve, I asked you to factor. There's no equal sign. The other way to do this problem, known as splitting the middle term, and again, I don't care how you factor, you get to do it however you want. Splitting the middle term is also a very important method to know how to solve, also known as grouping. So this becomes 3x squared, and if you take the sides of your diamond, which was minus 1 and minus 9, and add an x to it, you'll notice that when you add negative x and negative 9x, you get negative 10x. And grouping says you're going to take the first two terms and put them together, and you're going to take the second two terms and put them together. And then you're going to find the GCF. So the GCF of the first group is 3x, and that leaves you with x minus 1. And the GCF of the second group is minus 3, and that leaves you with 3x, not 3x minus 1. I made a mistake. I have to go back. Luckily, I found the mistake on my own. Let me go back. This is incorrect. The GCF of the first group is x. That leaves you with 3x minus 1. And then minus 3 times 3x minus 1. And you know how I knew I made a mistake? Because when you group, what's left in the parentheses must match. So that's how I knew, wait a minute, something's not right. So now the common factor is 3x minus 1, and x minus 3 is what's left. Notice that's the exact same answer that we got above. Grouping is important because in this last problem, the only possible way to factor this problem is by grouping. You must know how to group. Grouping meaning put the first two terms together and the second two terms together and then find the GCF. Okay, so the GCF of the first group is going to be x squared, and that leaves you with 2x minus 1. And the GCF of the second group is minus 4, and that leaves you with 2x minus 1. All these mistakes, in my defense, I haven't had any coffee yet today. So now what matches is 2x minus 1. And what's left is x squared minus 4. So the 2x minus 1's match. That's the common factor. And if you factor that out, you're left with x squared minus 4. This is not done. X squared minus 4 is the difference of two squares. It is by far the most common factoring pattern. If I had to guess, between now and June, you're going to be using the difference two squares like 100 to 200 times. No joke. This factors as 2x minus 1, x plus 2x minus 2. I do not care how you factor. If you learned guess and check, you don't need to show an ounce of work. That's totally okay. You factor however you want. All right, there we go. Okay, again, I'm going to ask you to pause the video, and I want you to complete the square on Monday's quiz, complete the square, and convert the equation to vertex form. Okay, so vertex form, x minus h squared plus k. The vertex is at HK. A tells you it's a parabola, open right side up. Is it a reflection? Is it really wide? Is it really skinny? So pause the video after I give you the problem, and we're going to convert. So the equation I'm going to give you is y equals negative x squared plus 4x plus 5. Take a minute, try it on your own. All All right, let's see how you did. Subtract 5 from both sides. That's how you always start with completing this square. The key thing here is that A is not 1. To complete the square, A must equal 1. So whatever A is, you need to factor it out. So if A was -2, you'd factor out a -2. If A was -16, you'd factor out a -16. If A was positive 2/3, you'd factor out a 2/3. If you don't need to make the square itself, if you know how to divide B by 2 and that's how you were taught, fantastic, you go for it. So my first box is going to be x squared. I'm going to split the -4x into -2x and -2x. Notice that this is still -4x. It's still -4x. I just cut it in half. So now the key question here is what goes missing in the box, and the answer to that is +4. And this factors as x minus 2 times x minus 2. So I'm going to add 4 inside my parentheses, but you did not really add 4. What you really added was, in this case, you subtracted 4. So this becomes y minus 9 equals negative x squared minus 4x plus 4. This factors, look at the dimensions of your square. It factors into x minus 2 squared. Okay, so I get a lot of questions about what happened to this 4? Like, where did this 4 go? The x minus 2 dimensions of this square, so x minus 2 and x minus 2, is the equivalent of x squared minus 4x minus 4. So all you have done is rewritten it. It's in a different form. The 4 is hidden inside there. So this is going to be y minus 9. Oops, no. Add 9 to both sides, and this is negative x minus 2 quantity squared plus 9. The vertex is at 2, 9, and this parabola is a reflection over the x-axis. Okay. I want you to find the y-intercept and the x-intercepts. Again, pause the video, find the x-intercepts and the y-intercepts. Y-intercept of every function in your entire math life, you're going to set x to 0. All right, there's 2 ways you could have gone about this. You could have used the original equation I gave you, which in my opinion is probably the easier way to go. So I'm just going to rewrite this. And if you plug in 0 for x, which I'm hopeful you can do off the top of your head, and y is 5. So that would have been, in my opinion, the quickest way to do it. Notation matters. The y-intercept is 0, 5, not y equals 5. Don't forget your notation. The other way you could have done it was from your vertex form. It takes a little bit longer, but it works. I caution you because if your vertex form is incorrect, your y-intercept is going to be incorrect. So if you plug in 0, you get negative 0 minus 2 squared plus 9, which is negative 4 plus 9, which is 5. Same answer either way. Which way should you do it? Don't know, don't care. Makes no difference. Okay. Finding the x-intercepts, you have options as well. So I want to be very clear that you must know how to do the x-intercepts using both forms. Again, you need to be able to find the x-intercepts from standard form as well as vertex form. Okay, so I'm going to start with vertex form. So the vertex form that we got was negative x minus 2 squared plus 9. So if I want to find the x-intercepts forever, you're going to make y 0. So that's going to give me 0 equals negative x minus 2 squared plus 9. Subtract 9 from both sides. Divide by negative 1. Or multiply by negative 1, whatever. So that gives you 9 equals x minus 2 quantity squared. Do not multiply that out. It's not going to help you. Square root both sides. They are called inverse operations. When you square root a square, I don't like to say cancel. It's not a great math word. All right, the key thing here is that the square root of 9 is plus or minus 3. Square root of 9 is positive 3, also negative 3. When you're solving, there's 2 answers. So now I'm going to add 2 to both sides. And then I'm going to simplify. So this becomes 2 plus or minus 3, and that's going to equal x. And then you can simplify that. So x is going to be 5 or negative 1. Notation, notation, notation. The other way to do it is via standard form. And the standard form problem I gave you was negative x squared plus 4x plus 5. Okay, so I'm going to factor this, set it equal to 0, and I'm going to factor it. I find it difficult to factor if a is negative, so I'm going to divide or multiply everything by negative 1. And do your diamond or group or guess and check, whatever you want. Even I use the diamond occasionally to help me with my guess and checking. So when you factor it, you get x minus 5, x plus 1. And then there's this beautiful thing called the zero product property. Sometimes I like to say we're going to zip ZPP, we're going to use the zero product property. You can skip this step. I'm showing it for video purposes. Set each factor equal to 0. And so that's going to give you x is 5 and x is negative 1. And of course, notation. Okay, that's a lot of work. And then we're going to go ahead and sketch a graph. We're going to put all of these values on our graph. We'll see how I do here. So my vertex was at 2, 9. 1, 2, 3, 4, 5, 6. Oh, I made it just in enough space. So 2, 9. My y-intercept was at 0, 5. And my x-intercepts were at negative 1, 0, and 5, 0. For every point on the parabola, you know 2. 1 point actually yields 2 points. Parabolas are symmetric, so you can like cut the parabola in half. And so the book will ask you for a reflected point or a symmetric point. They mean the same thing. So if I reflect the y-intercept to the axis of symmetry is 2 spaces, and I'm going to go 2 spaces the other way. So a reflected point would be 4, 5. And then I'm going to try and draw a parabola. Let's see how it goes. Oh, not too bad. Not too shabby, if I do say so myself. And there you have it. Okay, so now that I put you through all of this torture, there are some shortcuts that you don't have to complete the square. I'll be honest, I do not like completing the square. Completing the square drives me nuts. But it is a good way. It's like if there's construction on the way from school to your house. You need to know multiple ways to go from, home to school. Look at campus. You have to know multiple ways to get from, the science wing over to the, 800 wing. So having multiple methods of doing things is helpful. So I'm going to go back to this very same problem again. And the shortcut, this is standard form. I'm anticipating here. The shortcut to finding a vertex in standard form, the x-coordinate of the vertex, drum roll, is opposite of b over 2a. Don't say negative. Negative b over 2a implies that the problem's always negative, and it's not. It's opposite. So I recommend labeling ABC. You'll make fewer mistakes. And if you make a mistake, I can give you partial credit. So the x value, we know from previously that it should be 2. So the opposite of b is negative 4 over 2. A is negative 1, and that is indeed 2. Cha-ching! And then to find out what the y-coordinate is, I'm going to plug in y-coordinate. I think I might have messed that one up. So to find the y value, so 2 squared is 4. The opposite of 4 is negative 4, plus 8 plus 5, which is indeed 9. Miss Babiak, do I have to complete the square? You have to follow the directions. The directions say complete the square. That's what you need to do. I'll make you complete the square on Monday's quiz. I'll probably make you complete the square on your next test. But after that, I'm not going to make you complete the square. Okay, very, very last thing. Hang in there, last thing. I'm going to give you a parabola, and I'm making this up off the top of my head, so it's probably going to be gross. 3x squared, how about plus 12x minus 11, let's say. And I want you to find all the things. Okay, so let's start with the opposite of b over 2a. I'm not completing the square. We're going to do opposite of b over 2a. So a is 3, b is 12, and c is negative 11. So the x-coordinate of the vertex is the opposite of b, which in this case is negative 12, over 2a, which is 3, which is negative 2. To find the y value, this is not on Monday's quiz. This is not on Monday's quiz. And we'll do more of this on Monday. I'm sure you can't wait. So this is going to be negative 2 squared, which is 4, times 3 is 12, minus 24, minus 11, which is negative 12 minus 11, negative 23. That's a horrible vertex, but it is what it is. Could you imagine completing the square with that? No, thank you. Minus 2 minus 23. Okay, and I'm not going to find all of the x-intercepts. I am going to show you a little, it's not necessarily a trick, but I'm going to refresh your memory, something you may or may not remember. If I asked you to factor this, you could spend a lot of time making the diamond, doing guess and check, trying to figure out what works. So, you make your diamond, or you're trying to guess and check, whatever, and you get negative 33 on the top, and you get 12 on the bottom. And you're playing around, and it's like, well, 1 in 33, that's not going to help. Or maybe it's, negative 11 and negative 3, and you're playing around and you're playing around, and you just can't figure out what works. Right. So there's a shortcut to help you figure out whether or not a problem is factorable, and that is the discriminant. I'm hopeful that a lot of this is refreshing your memory. If you're looking at this and you're like, I have no idea what she's talking about, plan on coming to tutorial. This is not on Monday's quiz. The discriminant is what's underneath the square root for the quadratic formula. Quadratic formula, opposite of b plus or minus the square root, b squared minus 4ac, all over 2a. There's a song. Okay, enough singing. So if the discriminant, b squared minus 4ac, if the discriminant is a perfect square, then the function is factorable. If the discriminant is a perfect square, then the function is factorable. Perfect squares, you need to know the perfect squares without a calculator up to 15. So perfect squares would be 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 25, 36, 49, 64, am I forgetting one? 81, 100, 121, 144, 169, 196, 225. Yes, I know, I just zipped through that, but these are the perfect squares 1 through 25. I'm sorry, 1 through 15. You need to know these without a calculator. All right, that is a lot of information. So you have a quiz Monday. Monday's quiz is on graphing a single parent function, any parent function I want from that gold sheet, 1 completing the square problem, and 1 factoring problem, 1 of each. All right, the homework is on the board, and I will collect the homework that was due today, the book and the parent function worksheet. I will collect that on Monday as well. Have a great weekend.